Welcome to all. Today we will study the topic centroid. We know that in engineering mechanics we deals with the different types of the forces and point of application of force acting on the object. Centroid and center of gravity are also the point at which whole mass and area is supposed to be concentrated. Center of gravity is the point about which total weight of the body is supposed to be concentrated. But this word center of gravity generally used for three-dimensional figures, means the object has length, width and height. It has mass. Whenever a three-dimensional figure is there, the point about which whole mass is supposed to be concentrated or whole weight is supposed to be concentrated will be considered as center of gravity of the object. The basic difference between the centroid and center of gravity is the term centroid is applicable to two-dimensional figures. The two-dimensional figures means, for example, a piece of paper. It is also a three-dimensional figure, but as compared to its length and width, the thickness of this paper is negligible. That's why we are not considering the thickness. Just we will consider this piece of the paper as two-dimensional object. Whenever there is the object is of two-dimensional, means it has the area which is most important, which we have to consider. That's why when two-dimensional figures are considered, the point about which whole area of the object is supposed to be concentrated is called as centroid of the object. Whole area is supposed to be concentrated. That is called as a centroid. This term centroid will applicable to all two-dimensional figures, or the figures or the objects in which the dimensional one dimension is very less as compared to other two dimensions. Length and width is considerable, but as compared to the length and width, if thickness is very small, then we have to consider only length and width, and that object will become under the category of two-dimensional figures. In centroid, in generally, the centroid is the point of geometric center. Means centroid will lie on the geometric center of the figure. In standard figures, we know that what is the geometric center. For example, if it is a rectangle, then in rectangle we know that the midpoint of width BD, then this point D by 2 and B by 2 is the centroid of this rectangular figure. For circle, the center of the circle is the centroid of the figure. Likewise, for the standard figures, we all know what is the geometric center. But whenever the irregular figure will come, how to determine the centroid of that irregular figure is very important. Means irregular figure means it may be of any shape. This is the shape. We have to find the centroid of this figure. For this, we have to use the geometric center of standard figures. It is not standard figures, it is irregular shape. So for determination of the centroid of irregular shape, I will divide this given figure into standard figures. Means first standard figure is triangle and second standard figure is rectangle. I will use the value of centroid of this triangle and rectangle to determine the centroid of this irregular figure combined. For determination of the centroid of the irregular figure, we require the centroid of the standard figure. We will write the centroid of standard figure here, which is already known to us, but for understanding, I am writing if it is rectangle having width b, depth d, then this centroid is d by 2 and d by 2. Area of centroid is b into d, and x y coordinate, I will say x and y coordinate is refers to this axis x and y. It is x is the distance measured from y axis, therefore it is d by 2, and y is the distance measured from x axis, it is x is the distance measured from y axis. Here it is b by 2, means here it is b by 2, and y is the distance measured from x axis, that's why it is d by 2. If it is a triangle, right angle triangle, having height h and base b, then the centroid is lying at this point at a distance of, from height it is b by 3 and from base it is h by 3. Area is given by half base into height, and x axis, x coordinate is the distance measured from y axis. The y axis, if we will say this is the y axis, it is x axis, then it is from y it is b by 2 and not 2, it is h by 3, b by 3 and h by 3. This b by 3, h by 3, x and y coordinate is as per the given x and y axis. Whenever the position of the axis will change, we will calculate the x and y coordinate with reference to the given axis. Third figure which is standard figure, is a circle. Assume that a circle is there, axis is lying like this. From standard figures we can know that the centroid of the circle is center of the circle. Area is given by pi r square. X and y coordinate will be r and r. Again I am repeating. This x coordinate and y coordinate is with reference to this given axis. If position of the axis will change, for example, I will change the position. For example, position is at this point x y. This distance is 2 meter. This distance is 3 meter. Then ultimately area will not change, but coordinate of x and y will change. How x will change? X is the distance measured from y axis. So the distance of the centroid from y axis is r plus 3, and distance of centroid from x axis, that is y coordinate, is r plus 2. But we have to remember that in circle the centroid lies on center of the circle, and the fourth standard figure is semicircle. Assume that if y-axis and x-axis is given, then in semicircle the geometric center is this point, which is at a distance of r from corner, and this distance from diameter of the circle is 4r by 3 pi. 4r by 3 pi. If area of the same circle, it is pi r square by 2. X coordinate is the distance measured from y axis. The distance of this centroid from y axis is r, and y coordinate is the distance measured from x axis. Therefore, it is 4r by 3 pi. Then there is one another figure, that is quarter circle. In quarter circle, the geometric center lies here. The distance of this from axis is 4r by 3 pi, and here also it is 4r by 3 pi. It is x, it is y. The area is given by pi r square by 4, and x and y are given by 4r by 3 pi, and here also 4r by 3 pi. The standard figures and the centroid from reference axis, we have to use semicircle, quarter circle. Then there is one, that is sector of the circle. The sector of the circle, if sector is like this, x axis and y axis having the included angle alpha, and radius of sector as r, then area of the sector is r square alpha, and x 2r sin alpha divided by 3 pi, and y coordinate will be 0 because here it is lying at this point. This distance is 2r sin alpha divided by 3 pi, and y is the distance measured from x axis. Therefore, the centroid is lying on x axis. That's why the value of coordinate is 0. So we have to remember all these standard formulas, and remember these values 4r by 3 pi, 2r sin alpha divided by 3 pi. It is given from these reference axes. Whenever the reference axis of the figure will change, ultimately the x coordinate and y coordinate of the centroid definitely will change. For example, very simple. Assume that it is a semicircle. It is x axis, it is y axis. We know that in semicircle the centroid is at a distance of from diameter is 4r by 3 pi, and this distance is r. If x coordinate are required, x and y, then x is the distance measured from y axis, so I will measure this distance. I will not write only r, because r is the position if axis is lying at this point, but axis position is shifted. That's why we have to consider this length also. If it is 2, then x coordinate will be 2 plus r. And similarly, y coordinate we will not directly write 4r by 3 pi. What is y? Y is the distance measured from x axis, so we have to consider this distance also, because distance of this point from x axis we have to measure. If it is 3, then 3 plus this distance, 3 plus 4r by 3 pi. And it is not compulsory that always the semicircle will have the same position. It may be like this. If this is 1.5 and this distance is 5, x and y. If I have to find the centroid of coordinate of the centroid, I know that the coordinate is the centroid is lying at this point. This distance from diameter is 4r by 3 pi. Depending upon position, orientation, the value of the coordinates will change. So I will calculate. If x I have to calculate, I require distance from this y axis, total distance, This is the 5, 5 plus 4 are by 5 plus 4 are by 3 pi. And y, this required this distance from x axis, so 1.5 plus r. Like this. Means depending upon the position of the standard figures and position of the reference axis, we have to measure coordinate of centroid. But question is, why we are finding this? Because in general the figure is of irregular shape. If irregular shape figure is given and we have to determine the coordinate of the centroid, then the first step is divide the figure into possible number of standard figures. Possible number of standard figures. It is the first step. For example, if I will that is the figure. It is a irregular figure directly. I don't know what is the geometric center I need to find. That is the first step. Divide this given figure into standard figures. Means I will divide this figure with dotted. The first is rectangle and second is quadrant. It is the process. If there is 3 standard possible, there is maybe more than one combination is possible. So we have to see which one is easy. After division, calculate the coordinates of centroid about given axis. Coordinates of the centroid about given axis. Means we have to find coordinates of each standard figure with reference to given axis. After this calculation, we will use the formula for calculation of the centroid x bar equal to a1 x1 plus minus a2 x2 plus minus an xn divided by a1 plus minus a2 up to a. This will give you the centroid of the irregular figure. A1 is the area of first standard figure and x1 is the coordinate of the centroid of first standard figure. Similarly, A2 is the area of second figure, x2 is the x coordinate of the centroid of the second standard figure. If there is n number of figures, this formula will extend. Plus minus sign is depend on the mass. In some problem, the figure may be like this. Means figure will be a plate with circular hole. Then these standard figures, this irregular figure, we have to find the centroid. Then we will divide this irregular figure into standard. Very easy. Here it is a rectangle and circle. These two standard figures are possible. But rectangle has mass and circle is hollow part. When circle you will put value of circle, area of circle we will put here, we will use negative sign because it doesn't have mass. Hollow part should be with negative sign, and if mass is present, then we have to consider positive sign. Okay. Similarly, we will calculate the coordinate of the centroid of y coordinate of the centroid a1 y1 plus minus a2 y2 plus minus an yn divided by a1 plus minus a2 plus minus an. That is the formula for centroid of y coordinate of the centroid. Okay. I will repeat the step how to calculate the centroid. For calculation of the centroid, first we will see the irregular figure and we will divide the irregular figure into possible number of standard figures. It may be 1, 2, 3, 4, 5 or n number. After splitting in number of standard figures, we will find area, x coordinate and y coordinate of the centroid of standard figure with reference to given axis for each figure. For each figure I will calculate the area, I will calculate the x coordinate of the centroid and y coordinate of the centroid. After calculation I will use this formula x bar equal to a1 x1 minus a2 x2 minus or plus a2 or x2 plus minus up to n number divided by a1 plus minus a2 to n number. Similarly for y bar I will use the formula. It is very easy. Now the very important point is you have to remember the axis of the symmetry. The axis of the symmetry means if this figure is given and we have to determine the centroid with reference to the axis which has given position. In this case the axis dividing the given figure into two equal parts. X axis is dividing the figure into two equal parts, upper half and lower half, and y axis is dividing the figure into two equal parts, left and right. In this case the centroid will lie on center of this axis, and when centroid is lying at the center of the axis means the position, the coordinate at this point is 0 0. Therefore the coordinates of the centroid is x equal to 0 and y equal to 0. Whenever the figure is symmetrical about both the axes x and y, whenever the figure is symmetrical about both the axes x and y, x coordinate of centroid is 0 and y coordinate of centroid is also 0. Now listen here, it may be that there may be a possibility that x, y is lying here and x is in between. In this case only x axis is dividing the figure into two equal parts. X axis is dividing the figure into two equal parts and y axis is at edge of the rectangle. In this case the x coordinate and y coordinate will be, x is the distance this point, y coordinate will be 0, and x this distance if it is b by 2, therefore the coordinate will be b by 2. If the figure is symmetrical about x axis, y coordinate is 0, and if the figure is symmetrical about y axis like this, y axis is dividing the figure into two equal parts, then x coordinate of the centroid is 0, because the centroid is at this point which is located on the y axis. X coordinate means it is the distance measured from y axis, that's why x is 0 and y has value of, if it is d, it is d by 2, like this. This symmetrical figures we have to directly we can get the value of the centroid for the figures. Again I will repeat this. Whenever the body or the object or the plane lamina is symmetrical about both x and y axis, the coordinate of the centroid x and y is 0. If body is symmetrical about only x axis, y coordinate is 0. If body is symmetrical about only y axis, x coordinate is 0. Means if axis position is given such that it is dividing the figure plane lamina into two equal parts, then no need to find one coordinate, only we have to calculate the value of the coordinate with the help of this formula. It is very easy. First I will divide the given figure into the number of possible standard figures. Second I will determine the centroid, coordinate of the centroid for each standard figures and area. And in third I will use these formulas to calculate centroid of irregular figure. We will see numericals on centroid in next lecture, and after that there is a very important topic, moment of inertia.